Good morning, everybody. My name is Mostafa Elghazawy. Just before beginning the telling you the subject of my presentation, I'd like to ask you a question. Does anyone know what is happening inside it?
No.
You should have known now. Okay, it's called plasma. And as the start of my presentation, I'm going to tell you about what the plasma is, and then I will move on to how plasma television works. But just let me tell you my story with plasma. All these past years, I have been learning that the states of matter are three: solid, liquid, and gas. And if you have a solid and you heat it, it's going to turn into a liquid. And if you heat the liquid, it's going to turn into a gas. However, from 2 years ago, while I was searching about how plasma television works, I found a very strange article written by NASA. This one. I just want to point to this sentence. The fourth state of matter. I swear, when I saw it, my face expression turned like this big. And after searching, I found that if you have a gas and you heat it with a tremendous amount of heat, it's going to turn to a new state of matter called plasma. But before telling you more about the plasma, I just want to revise some about the atom. As you can see, the atom has an electron. The electrons are moving in orbits. They are the negatively charged particle in any atom. But what makes the plasma unique is its electrons. Because of the tremendous amount of heat the plasma has, the electrons are vibrating too much that they are forced to leave their energy levels, and they are moving freely. And it's interesting to know that all the stars, including our sun, are in plasma state. And that's because of the enormous amount of heat they have. And after conducting more research, I found that you need an approximate amount of heat of 3000 Celsius degree to create a plasma. And as we all know, this amount of heat, if you put it inside any device, the device is going to melt immediately. So how can plasma displays have plasma inside it? Does anyone know the answer? Okay, I'm going to tell you. There's actually an alternative way to create a plasma. It's by supplying electricity to any gas. When you are supplying electricity to any gas, the electrons will vibrate too much, and they will leave their orbits. And in that way, they are going to move freely, and the gas is turned to a plasma state. I'm moving into the second part of my presentation, is how plasma television works. Inside the plasma screen, you have millions of pixels, and each pixel has 3 subpixels: blue, green, and red. And inside the subpixel, you have a mixture of 2 gases, xenon and neon. They are noble gases, which means they are not reactive to any other element. And when you are supplying electricity, these gases are turning into a plasma state. And after a very short period of time, the plasma television automatically removes the electricity. And when the electricity is removed, the electrons are returning back to their energy levels, and the plasma is returning back to a gas state. But while the electrons are returning back to their energy levels, the electrons will start emitting ultraviolet rays. But what do I need from ultraviolet rays? As we all know, the ultraviolet rays are invisible for human eye. That's actually why the subpixel is coated with a material called phosphor. One of the abilities of the phosphor is that it can absorb ultraviolet rays and it produces a visible ray. This visible ray can be blue, can be red, can be green. It depends on the type of the phosphor we are using. And actually, the fluorescent lamps are using the same concept of plasma that is used inside the subpixel of the plasma television. As you can see in the fluorescent lamp, it is coated with phosphor and it is using ultraviolet rays. So I have I brought with me some fluorescent lamps. They are special. These three are coated with the same phosphor that the plasma television were coated with. Look what is happening when they come near ultraviolet rays. They absorb the ultraviolet rays and produce a visible ray. Okay. And moving to the next part is how plasma television can maintain too many colors. As you can see, as I said before, there are millions of subpixels, blue, red, and green. Let's say I want to produce a yellow light. So I will only supply electricity to the green and the red subpixels. And let's say I want to bring a white color. So I will supply electricity to all the subpixels together. And by varying the intensity of light, I can maintain even more colors. And if, let's say, I want to create a black color, I just don't need to add any electricity. But how electricity is supplied to the subpixels? Is it some kind of wire attached to each subpixel? Of course not. Because the subpixels are very tiny, we are using vertical transparent electrodes and horizontal transparent electrodes. Together they look like this. Let's say I want to light this subpixel. So I will only supply electricity to this electrode and this electrode. And because and after I have seen how fascinating is the plasma, I had a curiosity. I wanted to try and create a homemade plasma. And that is what happened with me. And because of because creating a plasma would be a mission impossible, I went directly to the physics department and asked them for help. And they gave me this amazing advice. As you can see here is the plasma. And that brings me to the end of my presentation, so I will summarize quickly what I have said. The plasma is a fourth state of matter, and both the fluorescent lamps and plasma divisions are coated with phosphor material and create too many colors. And inside the plasma television, you have the xenon and neon.
You're good on time.
Okay. So I recommend and using the phosphor, the ultraviolet, the phosphor will absorb the ultraviolet rays and emit visible colors. And I recommend that we add the plasma to the high school syllabus because I really think it's important and interesting. Thank you for your attention. Because I didn't know it's 10 minutes. I thought it's deep.
No, you're fine either way. I got part of the video.